The assignment is this. So I think so let me share my screen. I can give you the assignment. So I know um, uh-huh. Okay. Can you see my screen?
The one you
Hello?
are sharing has disappeared.
What happened? Okay, let me
What we
just
just see now is a blank screen. Share again, please. Thank you.
okay, yes, sir. So let's see. In the toilet you. Hmm. So let me ask each one of you. Maybe I want you to go and study Zika virus. Hello, Zika. This is the first model that I'm thinking of. I will give you. Can you see my screen now?
Yes, I see your screen.
Yes, you can see it.
Yeah. This is the model that I want to give to you. Maybe now you can. I don't know if I'm convenient like this. I want to show my face. So, but I don't think it's necessary. So it will be good that you are. So now the first question is this: in the next complicated of our drug clearance. So this drug clearance mean that division of drug. A patient is given in an infusion. The drug is added at a constant rate. That is the uh, alpha to a blood B. From there, it diverges to muscle at the rate of gamma, and there metabolize, that is destroy the drug at the rate of lambda. The first question they ask is that draw the compartmental model, write down the differential equation, solve the systematic analytics, and verify your solution. Can anyone have idea of how this thing is going to be? Do you have any idea? You just to think, because this section is just for practical. As we go up, we develop a project on this. So that is the main aims of it. It's not for you to go and you have to be teaching. No, what you learn, you develop a practical. So what? Who have idea on this? Is there any idea?
Let me give it a try.
Okay, go ahead.
From the look of the current one you did, I can see that if I superimpose this on that, it's there's a bit of similarity.
Yeah.
The infusion rate, as the constant rate of alpha, we can liken it to birth rate in the other one.
Exactly. Yeah. It's true.
Now, then the diffusion rate now might mean maybe death rate. The weight at which it is living
Yeah.
minus.
Yes.
Then the muscle metabolizes again is going to be another minus again at the constant
Yeah.
rate of empty.
Yeah.
So if I study the other one properly, I can
Yeah.
superimpose those things you've done. I hope the
Okay.
last class was recorded because if I look at it, I can see
The
in quotes, the
similarity, right?
magic you were doing. I can be able to copy it and do it on this one too. We should be
Yeah.
able to
Now
copy it.
look at this. Look at this. What we did before. Look at this. What we did before. So we're supposed to do something. Maybe we just take a reverse of this. Is not a problem. Let's do it. Let's just some little revision on this so that you get it the concept clear. Because this work is depend on the project you're going to do. Also work on data science depend on project that you're going to do. So that this seminar is just for presentation. You don't have to come and present. not say that no, you have to come and present yourself what you understand weekly. That is the aims, not for us to tell you this and that. They say what at a time when a total amount this of radioactive isotope, the isotope decay at this. So this means let me go to board. Um,
Please save this board so that we
yeah.
can have access to it. Yeah, save it so that we can share it with us later.
Okay, I should
There's
save
a
it.
way you can save the board. Yes.
Um,
I'm sorry, I've already recorded everything, but still it's fine.
Okay.
Yeah.
okay, I think that's fine. So now let's do like this. So now I think the place is convenient now, and I can if you want to see my ugly face, I can show you. Mhm. So now that is it. You see what at a time t, that is the period, we have a total amount of IT of radioactive isotope. This isotope decay at this rate. So decay mean what? It exists. So you have something like this, your compartmental model. Wow, sorry. I don't know what happened. Why? Try to see. So if I cannot draw a model with this, I try to draw a model, but it does not look nice. Let me just manage like this, but it does not look nice. I don't like it. So let me see what I can use again. Mm-hmm. No worry, I'm coming it here. Just assume this model, just a random drawing. Like my hand is shaking, I don't know what happened. So is decay, this decay at rate of what? At rate of this, at rate of this. I hope you can see my full screen.
Yes, we can see it.
Okay, at rate of this guy. So this is total amount of what is inside. Total amount of what is inside is this guy. Total amount of what is here. So it decay at rate of lambda I t, yeah, this at rate of a decay. So decay means a minus. That's what it means. So when you get the differential equation of this, that's why you get this guy. Changing in I of changing in t, you have minus of this. So when you solve this one using the method that we used before, maybe you can go and try it. If you didn't get it, come back. We are going to solve it. Or during this section, the my core instructor will work on that. So that is the first one, first simple example. So this is the graph according to that one. That one you can also try the graph when you install it. The next time, I hope we all have system because this cannot be done without system. So secondly, this second model, another simple model. We have a lot of complicated model. Another simple model is this. Yeah, this one they're just telling you. You can just go to it. They say that G amount of sugar and B amount of sugar amount of in the gut intestine, B amount of sugar in the blood, amount of sugar in the muscle. Draw a compartmental model for the following system of differential equation. Explain explain the different term in the following system of differential equation. They only give this differential equation. Oh, I hope I'm not they only give this differential equation because you cannot answer this question. You cannot answer this question without understanding this question. So here, what do you have? You have a negative. Yeah, which means two things go out of G. One, it go out from G to what? To B. Two, it go out from this out. Then here, it go out from B here, B to M. Then here, it go out from what? Here, there's nothing go out. So here, nothing go out. What this going, what going to be? And here, dm of the T. Here is what coming into M and what going to D. So did you understand this model? That is first question. Did you understand this model? Let's know, do you understand the differential equation of this model? Forget about this equation. Do you understand this model? Can you form the equation with that? Do you
Eh,
understand it?
So, if I want to ask now, for the
Yeah.
uptake into the blood, me, if I can, yeah, I understand the biological
Yeah.
model in quotes,
Mm-hmm. Yeah.
but I want to now liken it to what we have mathematically here.
Yeah.
So, in the stomach now, which is G in blue,
Mhm.
sugar uptake now
Yeah.
into the blood from the guts now is the one where we have, what do you call that one before the G? What do you call that symbol?
This one,
That one, yeah, yeah, yeah.
delta, delta.
Delta, okay.
Yeah.
So delta dot G. It means that is it leaving? That is minus the one leaving from the
Yeah,
uptake
it's
into the
living
into the
exactly.
blood, going to the blood. It's going to the blood,
Yeah, it's
but
living.
from where? From the gut.
Yes,
That's
it's
from the
living.
stomach.
Yeah.
The other one now, that E, what do you call it? The symbol now for the G,
Epsilon.
epsilon. So epsilon is it meaning it's exiting because it's saying it's going into the toilet.
Yeah, it's in the toilet. Yeah, it
Let's
is.
leave that. So now, while in the blood now, from the blood now, I think we have another one going into the muscle from the blood, which is diffusion, which is a beta B.
Yeah.
Now the big B, what's supposed to mean there? Because okay, from the that is from B, that is minus from the muscle, from the blood into the muscle.
Mm-hmm. Yeah.
Then the mu M, that is the one the muscle is now consuming. So that one too will be minus in now from M. So all those
Mm-hmm.
things, all these three items now, that is delta G, epsilon G,
Mm-hmm.
beta B,
Mm-hmm.
and the mu M. All of them are minuses from these systems.
Mm-hmm.
They are
Yeah.
minusing from one going into the other. So
Yeah.
if you are
Yeah.
to come here now that the GDT, that's the rate of change in the gut per
Mm,
time is going to
mm,
be two things. The one that is being taken into the uptake into the blood, which is delta G and delta and epsilon G. Likewise, the same thing too from the blood too. The BDT, that's the rate of change of the sugar consumption, sugar concentration in the blood per time is going to be delta. Why are we bringing delta G again? It's supposed to just be delta beta B. Why are we adding delta G here again? That's what you have to explain because my logic is telling me it's supposed to be beta B alone. It's supposed to be in the equation here because that's the only thing leaving the blood now. As for the muscle as well, it's supposed to be the minus, that's a minus mu m because it is living. Except maybe you are saying we just need to put the remnant of what is left from the previous equation into it. Maybe that's why it's there. So that's my own understanding.
Hey Jafar, are you having network issue? Oh, I guess Jafar is having some issues with his
Wait for it.
technical
Wait
of
for
his
it.
okay,
audio.
you can
Wait
you
for
can
it.
hear me, right?
Yeah, you're back now.
Yeah,
Okay.
after I finished talking, we didn't hear anything you were saying, sir.
Ah, okay. Yeah, sorry. So I just see. Now, can you form a story with that? Can you form a story
I
with
think I
this
can,
model?
I think a story can be formed
Yeah, form your
based
story.
on
Let's
the
see.
biological model. You
Yeah,
understand?
yeah.
Now, particular amount of this thing enter into the gut,
Mm-hmm.
which is sugar concentration.
Mm-hmm.
Now, from the gut, now some enter into the bloodstream from the gut,
Mm-hmm.
which is a compartment. Gut is a compartment.
Mm-hmm.
Now it's going from that compartment into another compartment, which is the blood.
Mm-hmm.
Another one from that compartment of the blood, which is second compartment, now is going to the third compartment, which is the M.
Mm-hmm.
And while from the M, there's a final one which is diffusing out of it into a bigger one, which is maybe
Okay.
the muscle, consumption by the muscle. Muscle.
Um.
That's the one that is being left from the muscle.
Yeah. So I think for you to use somebody name, you need a permission. Can I use you as example? Or let me use another thing.
Go ahead, go ahead, sir.
Yeah. Let's assume that Abdul had a certain amount of blood, and at that rate, okay, let's assume that there's a certain amount of food in an intestine. Maybe you eat food, and maybe you can say that okay, you can say that oh, Abdul went to a Christian in his friend wedding yesterday, and he ate certain number of food, maybe around 200 meal of food. Out of this food, a certain number was converted to blood at the rate of delta.
Converted to sugar.
Yeah, so going into blood, some amount of sugar in the blood. So it's going into blood at the rate of delta. So some that are not be digested, it discharges to toilet at the rate of this. So the process continue so that they diffuse from the blood to muscle at rate of beta, and then from muscle the muscle consume all the food. After you finish eating, the food that you cannot be able to that your body need, it absorb it. So you can only discharge the one that is unwanted food in your body. So the remaining one you discharge it. But the one that cannot discharge, your body consume it. That's why you see here consumption. So you can form those type of story. So after form the story now, you get the story. You can use some friend, you can use another thing. So you look at how the model look like. This one, as I think you get the point. That is right. This, as we say, is going out is a negative. That is why here you see a negative. Here is going out is a negative. That's why you see a negative here. Here is coming into blood. That's why I see a positive here. This is why you see a positive here. So here is going
Okay.
out of the blood. That's why you see a negative here. Then here is coming out to muscle. That's why here you see a positive here. Anything that is received is a positive to him, because now from here this consume everything, taking it out. That's why you see negative here. So now you are done. That is the differential of this. Now, so this is a complex question. I don't want us to. Let's go back to our question. The question now, you see, you have seen a complex this. So you have to draw this guy. When you draw it, you're not in a physical meeting. I will have said let's have said we should. Let me draw it. But it's about to draw it. So you tell me what I will put. I want to tell me what I will put. How many compartments I supposed to have? Look at the question. Read the question. How many compartments I supposed to have? My question is too much, right? Hmm. Hello, can you hear me?
Yeah, we can hear you. You are going to have two compartments.
Yeah, we have a two compartment. That is great. So you tell me what I will put. What are you
Okay.
expecting me? What are you expecting me to put?
I'm very sorry. Oh, please hold on. I don't like that the fact that I'm the only. Am I the only student? I keep asking the question. All the rest lecturers,
So I think that is
apart from you and the modeling, you are the only lecturer. Others should talk. Oh, I beg.
but I think we should just face our business. So
Okay.
Hello, sir. You're not the only one. Although
I
I came very late to join you. That was that is the reason.
Okay. No, no, no worries. I just want to. I don't want to be. I'm afraid I'm dominating the class. That's why I'm watching. But let's go
You are
ahead,
not
Mr. Anafi. Then.
the only one. We are just following you. Myself. I'm following you.
Okay, sir. Thank you very much.
I don't know why you are so bothered by this. I don't know. So let's come like this. Um,
Hello, sir. I can hear you.
yeah.
Yeah, it's cleaning the board.
Okay.
So maybe I asked too much question. That's why you feel that guilty. I don't know. So I think I like interactive class. So everybody, yes, let's interact. That is why it's not like we just continue teach, 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 teach. We should have to interact. So now, um, let me draw the one. So sorry for this drawing because it does not look neat. I don't know why. So it's just like the model is. Maybe I will use another one, another this thing next time. But it will show clear. Or we use latex to draw it and share with you. But I prefer all this online direct class. Why I clean this guy? So you tell me which model and which model. Where will I put this first? Mhm. Wow, just accept it like that. So now you say it's two compartmental model. Oh yeah,
Yes.
now let's say this um yeah. Okay, in the next complication of our drug clearance, we want to give infusion. The drug is added to, so it added mean it coming into the blood. It coming into blood. So here something coming in. Wow, this is not nice. So it's not nice. Maybe we use a better word or pain cleaner instead. So, so here coming here at rate of what? At rate of alpha. At rate of alpha. Wow. Coming at the rate of alpha. Sorry for my alpha. Then this is the B into B. From there it derives into muscle at the
Go
rate
to
of
the B.
gamma B. From here it go here at rate of gamma A. Oh, gamma B. So we have something very good. Um, so this B, that is compartmental 1. This 2, that is M. So
M.
you go here, what happened Kuma again? Then what? It metabolize, destroy at the rate of this guy. So destroy mean going out. It destroy mean it go out. It's just use this. It go out to this here. At which rate? Of at rate of lambda m. Oh, it's my lambda m. So now what next is, I think differential equation does not, is not a problem. Who do not understand the differential equation of this model? So I think this is the two models that you can have using this statement. The first one is that draw the model, which we have done. The second one is write the systematic of this diagram to solve the systematic the system analytical, then verify your solution. Now what you do now is this will now be your assignment for today. Nobody has thought about this one. Nobody yourself, because we have not trained you. Yeah. So next week you have to present this. So you present this one, and then I think you have tutorial with my core instructor. So it's going to take you the tutorial. So you have to you make it PowerPoint. I don't know. Do you have system? Do you have system?
Yeah, I think I can get one.
Okay, you didn't have system.
Yes, we have system. There's a system.
You have do you have system?
Yes.
Yeah, I have system.
Okay, I think this can work for people that have system because so um Abdullah, you say you get one, right?
Yes, sir.
Yeah, I think so. Just maybe you work with Wasil, and then since you have a system, if you can have a Zoom meeting or in the group, you can join together. So
Okay.
I will ask my colleague to coordinate the work. So you have to present this thing next week. So you try to see a little. You write this is the story. You write the model. You write the differential equation. Then you try during your tutorial. Okay.
Okay.
Do you have a question?
Yeah, I have a question. The question itself, can we get it? Where can we have a copy out of it?
It's
Maybe sent
online.
to
It's online. Check
it's
your
online.
yeah.
Your
Check
material. Thank you very
yeah
much.
yeah yeah.
Uh,
Check the story
Okay. You said it is online.
yeah LMS.
uh, so
Check the LMS.
LMS. Okay.
Yeah. So it's there. I have so I have a bunch of questions, but I think like the way Abdullah said, I should not the speed that I want to come to work. I think is maybe it's too high. I don't know. Let me just make it more simple and easy with you. So we collaborate together and present this work. We present it next week. You get it? We present this, and then that is it. That is the main that are the presentation, so that you can be able to get the concepts much more. Yeah. You get the concept. Um, I don't know. That's you. Hello, that's you.
Yes. I'm
Yes.
So they have the assignment. I think you have the copy. So you take them to the assignment, and
okay.
let me just because I don't know my screen issue somehow. You take them to the assignment, and then you take them to they have to install their baking Madonna. You take them to baking Madonna. So this is the
Okay.
assignment. So they will do next week and present it next week.
Okay.
So little by little they will let's start from here. So this assignment, just only one year's assignment. We present it next week, and then next week also we do some revision and give you another assignment. So every week we have assignments. So we are in advance.
Yeah.
So I think it will take you through the work, and then anyone you don't understand is an expert also in that area. So he's an expert in that area. You take it too. So is there any problem that do you have any difficulty in what we have done today? Hmm?
From my own end, so far, if we look at the recording of today, if I look at it, I think there's no problem from my own end.
Okay, that is fine. Maybe just look at it. So now today we look at the this differential equation. So let me just add one problem to this. So sorry, let me add one problem. So the problem is just like example so that you get the concept very well. I don't want you to go home without getting the concept very well, especially this guy. So let's do another example using this. So this guy is a complex, and we can use a one time to solve it analytical. And please also this guy too try the solution of this question so that when you come back next week you will not be having because we have to do this guy next week. There's no way. It gives you like introduction to modeling. So you try to solve this differential equation, try to have a OD differential equation textbook, and then try to understand little differential equation. This is a small example of differential equation. So try to solve this guy too. I will ask about this. Try to solve it. So if you have any issue, you can also meet my colleague. So he's there in charge. So I will come next week and solve it completely so that you not be surprised for you that we are solving it. So let me add another problem for you. So here, going back to this, if they ask you to find the solution of this, find G here. They can ask you find G. They can ask you find the value of this G. So what you do, here you come back, you say G, the G, the G is equal to um, minus delta minus. I don't know why this thing is shaking now. But before it worked very well. Now. See my hand? Um, let me see the box. So, um, so here we have minus um, delta G minus um, what next? Epsilon G So I can ask you what is the solution of this differential equation. So what you do first is that you make this equal to, so this is like continuation equal to continuation. You factor this g out. You have minus g bracket delta plus this guy. So do you see, right? Then from here, uh, so from here you can say that changing in g here, so this all over changing in the t, as we know. So if this is all over 1, just give you a small headache. This all multiply. So from there you can have something like this. I know macrobiology people, they don't like mathematics. I know. I have my colleague, he don't like mathematics. So
Not that we don't like it.
I know. So I know in UG
Look
too.
at when you were talking of the bacteria now. It was very easy. One, multiply every 20 minutes. Straightforward thing. You understand? If they are dying too, you know it's straightforward thing. Every
Mhm.
30 minutes, two is dying, you know. It's
Mhm.
straightforward. Uh-huh.
I have all my colleagues when it come to maths now. So now when you multiply it, you get this
Yes.
guy. You have G
G equals to
uh, why?
minus DT
You
G
have this G
equals
um
to. So is it your mouse that is shaking or the system suddenly begin to shake?
I don't
But this
know.
other equation is clearer.
Yes, now means I'm surprised. That's why I have to come down and I call them on the station. Maybe it's my hand. So here we have G here
Equals
equal to here negative
delta.
G A. Now changing. I don't know why. We have to come down. Okay. So this does not show very well. So I think we have to find. So I have this. I have delta. Why not? This thing is looks somehow. You don't want me to do. I will do is yes plus epsilon. I have to change it up next week. So changing in t, changing in t. So from here you can divide. You can divide both side by g. Take both side by g, as we did here. Mhm. Divide both side by g. So divide both side by g. You have this This thing does not give me. Uh-uh. So, right. So when you divide by G, this guy by G is going to give you this. Let me just manage like that for G all over G. This over G is equal to uh, changing in delta plus epsilon all over changing in T.
Where's the negative now?
Just wait. So equals this. Just wait.
Okay.
So here you have your negative. Here you have your negative. Then from there you can integrate this guy, integrate this guy, integrate this guy. When you integrate both sides, what do you get in this side? What do you get in this side when you integrate this guy? What do you get? Hmm?
I from the
Huh?
last equation, I think is it going to be G
It's lim, not G. You get a lim G.
link G,
Yeah, you get a
then
lim.
exponential
Not exponential yet. Not exponential yet. Lim G is equal to what? Differentiate this one in the photo of what? Dt. Only is a dt here. So the time taken that
okay.
it took them. So here you have
See,
lim G
see.
is equal to here you have minus yeah. Mhm. We have to finish this today, even though we are not using you next time.
So,
Mhm.
Mr. Anas, you cannot make a request.
Yeah, can you guys
Since this board is shaking, this all this equation you are doing, if you can do it on a plain sheet and maybe send to the class.
just
No, we saw.
understand?
I
Just
understand it
understand.
like that. Okay, because for me to retrace my step now, after this class, now I have to sit down again and try to do everything you have done.
The benefit of this class is that even though when you are online, it's supposed to have a jot note that you use to judge yourself. As long as I say that we have to provide everything, so yeah, here is an advanced class, so it's not. So you're supposed to have something that you can use.
Before now, if I see the video now, okay, no problem, I understand. No worries.
Yeah. So I just have this. This
Lane
because
G equals
I have this.
negative.
So when you solve this guy, the difference is here you get a t here, and then plus c, that is epsilon. So I will share it and send it to you. That's not the problem. But when you have this thing, because next time I will find a way of using the beta board. So you don't need to provide everything for you. When you are doing it on board, you can have something that you have a chart. So that is also the set of a record too, so that we don't have to too much this. So here you have this integral of this. The difference that here is just to add t plus c. Then from here you can take exponential of both. then you have your G. So now after that one, you can try this also. You can try this and this. So try the 2B, but your main alpha to present is this guy.
Mr.
So
Anafi, I want to say something. For the first equation, there's no complaint. I have to go back again through the video and I will write it out.
yeah,
If I'm saying I should be writing the way you are writing now, I will not understand. First, I'm listening. So what I want to do now is because this one is not clear, that's why I'm making that request. I'm
okay,
not making that request based on you give me. It's because it's not clear. That's why I'm making the request. So that if I'm sitting down, I'm watching everything you are doing. I remember, okay, you did this step and step and step. Because this is the problem I have with Mr. Martins. He will write on the board, he will just clean it. He will write on the board, he will just clean it. How does he expect me to know it? So I abandoned the class for him. But I believe now I have at least now I'm a father now. So I should be able to follow what you are doing, which I'm willing to. That's the request I'm making. For this part of it, when the
so
board is not good. Sorry.
yeah,
Is the for this part.
okay, I get your point, but if you have any difficulty in this, I ask you that you will have a colleague when you have the, the tutorial class. So if you have any issue, you can take you can also ask him. And that's what I told you. So what we will find a way to because this does not show this before. I think I'm just explaining this now. So I'll find a way of using the beta board, and so that is it. But in that regard, I will solve that one and share it with you. But I don't think that subsequently I can do that for you again, for you guys again. So if I tell those people that follow,
I understand.
yeah, those that have followed that one, I will do that. So I think that is the this thing. So we have 5 minutes left. So we to see that what we did in terms of the back Madonna. Let's see out of what he did. With that one is not a problem. It's just like when you have a computer, you will install it. You have your arrow. You just arrow that is indicate where you are. And you're watching this your side, you call it a reservoir here. This side is showing which type of equation you are using. And here is showing the parameter. You see the parameter here. So this here is the same thing of what is inside this here. So this h, you call it the parameter, and that is parameter. So here we have something I call a global variable, but now you have not read that extent now. Maybe later we'll look at that. So that is what you need now, and that's our first graph. I also have another graph that I want to show today, but I think I don't have this is the graph of that diffusion that we showed before. And when I run the graph, you see this is how my graph look like. The one that I gave you, this assignment, okay, this one that I have, the diffusion graph. So this is the main graph, and then you see it look nicely, so it's very nice. So and when you check here, um, when you check our first class, first note, so you see the graph, so it's the same as the graph. So and these are the things that we need to do to understand it. So just go and let him guide you. Take through it. So this is your M. This is the blood taking. Here when you see the reservoir here, the changing in B of the T, and you see here we have a clearance. So plus division. So here it go out. So here you can also add your this one you don't get the level. I'm just explaining. Out of your meal, this maybe you don't want to use this direct, so you can add in this parameter. So that it's just like multiplication, but you have a division. So this is the blood, is when this is simple drug clearance. Also have the complex one. I also share you with the code. Maybe it also help you to formulate. So it's also the same thing as this. So it's also the same thing that what I asked you to go and do. So that is the solution. But if you want the parameter that I use here, you want the parameter, I can give you the parameter. That is fine. I can give you the parameter. So just to make sure that you understand the concept and you get the concept by the ends. So if you have any question, you can let me know. If you have any question, I think you have question. That's you. That's you.
Yes, Prof. Yes, Prof.
So I think the class is stopping by 8, right? Hmm?
8:30 actually,
So
which is 1 hour 30 minutes. So it's supposed to
so
stop at
let me
8:30.
let let me yeah let me because we have to take the class a little bit. So because of the person that we are speaking with, even the colleague, they are joining and they come back, join and come back. So
Okay.
we have to make it a so that if somebody that the official, you're 8:20, so 8 to 8:20. If it's artificial, we can, I think we can work effectively, but you need some background of mathematics, a lot of background. So to understand the concept, please during tutorial revise all this. Then if there's any difficulty and you try to install the baking Madonna and see how you can work effectively. So
Okay.
if you have difficulty, please contact him. You can also contact me direct. My email is there with him. Have your time to go through it. Have your time to go through it. So do you have any question?
Prof, when is going to be the tutorial?
Yeah.
Is it Wednesday or Thursday? The tutorial.
Now
I say, when is it going to be the tutorial?
check the timetable. I think
Okay,
the
okay.
timetable will,
That's our
yeah,
next class this week, right?
yeah. So check the
Right.
timetable. So
Okay. That's fine.
um Buhari, are you with us? Okay, so did you have if you don't have a issue, do you have if you have any question, if you have any question, please go and practice those things and contact him. He will help you out. So you can also contact me directly if you have a difficulty. But maybe if you are free to contact me, you can contact me. I have my email there. Just chat me. I will respond. If you want to contact him directly, you can also chat him. He will respond. So you don't have any problem. But we don't need to rush you because the background you need a more of mathematics to understand a lot of things. So um, thank you. If you have any question, you can ask. If you don't have a question, then we can just um, just just go and practice it. Then we meet. So now I know the level of the people that we are working with. So I think we know how to make it more simpler next time. Yeah. Are you with me, Abdullah?
Yes, I'm with you.
Yeah. If you have a
Thank you very
question,
much.
you can have. If you don't have a question, then maybe you
I
can
don't
just
have a question at the moment.
go and practice it and
Yes,
with.
that's what I would do.
Okay. Thank you very much. Have a nice day. Thank you.
Thank you, Mr. Jafar, for the wonderful class.
Thank you, Prof, for the class.
Yeah.
You have a wonderful day. Good night.
Okay. Thank
Mr.
you.
Abdullah, please do help yourself to download the materials from the AML so that you equip yourself before the next class.
Very nice class. I will do that tonight. Thank you very much.
Yeah, you're most welcome.
Yeah.
So to meet tomorrow for data science.
You can stop.